right, page 237 math boxes. I'm going to review your work and your answers. Remember, as I'm working through it, if you think you have an idea, don't just copy down what I'm doing, but if you weren't sure and you start to kind of get an idea, hit pause, work through it, and you can always press play, see how you did, go back, try again. So initially, they want to know the measure of t. So we have three angles here. We have t, which is the unknown, and we have this one right here, which doesn't have a label, but we know that's 130. And then we've got angle AB here, which is just a straight angle. There's a lot of different ways that you could write your number model with unknown. But the way that I would have probably done it is, I know that a straight angle, I know that both of those together equal 180 degrees. I know that one of the angles is 130 degrees, and then I'm adding the letter t to that. So 130 plus t equals 180. Some other ways that you could have written this, could have gone 180 minus 130 degrees equals t. And you could have just had, or 180 degrees minus t equals 130 degrees, or you could have had these flip-flopped. But either way, that doesn't really matter. Any of those would be acceptable. To actually solve it, you could add to 130 to get up to 150, or you could subtract. If we go ahead and subtract 180 minus 130, 0 minus 0 would be 0. 8 minus 3 is 5. Although we know it's not an 8 and a 3, it's an 80 and a 30, which gets you 50, because it's in your tens place. And 1 minus 1 is 0. I'm not going to put that 0 down. So the answer is t would equal 50 degrees on that one. On box 2, we're using a picture or a number model to show how we solve this problem. This is just multiplying a fraction times a whole number. It's what you did in the lesson for the actual page we did for 7-4. So it takes 3/4 of a cup of buttermilk. We're making 3 batches, so it's 3/4 times 3. We know that we need to make that whole number into a fraction, which is just 3 over 1. Then you multiply straight across. Numerator times numerator equals numerator. Denominator times denominator gives you your denominator. So go ahead, if you haven't done this, hit pause. You can work through that. I've got you kind of started. You do this work, and then we'll go over it together. And 3 times 3 is 9. 4 times 1 is 4. Now, this is a correct answer. We've talked about that the last few math boxes. 9/4 would be an okay answer, but that's going to make it hard to answer this next part. It's just a little bit lower here. What two whole numbers are those between? So we need to divide those to make it into a mixed number. 9 divided by 4. And you're thinking, what times 4 gets you close to 9? Or how many 4s could you count by without going over 9? And the answer to that is 2. 4 times 2 is 8, and we subtract. Multiply your divisor by your quotient here, and that will get you your number to subtract here. 9 minus 8 is 1. Okay, so in this kind of setup, your whole number is 2, your numerator is 1, and your denominator is 4. So 9/4 is equal to 2 and 1/4. I'd really like you, when there's a label or like a measurement, cups, miles, feet, I'd really like you to do this step of putting it back as a mixed number rather than an improper fraction. Okay, so between which two whole numbers is that located in? Well, if we were drawing this and each of these circles represent a cup, we would have 2 full cups and 1/4 of a third one. So it's bigger than 2, but not quite 3. So it's in between 2 and 3. 1 whole, 2 wholes, 3 3 holes. Okay, on this one, Carol ate 5/6 of her granola bar before lunch. Which of the following shows how much she has left? Well, the whole thing then would be 6/6, and 6/6 minus 5/6. Denominator is going to stay the same when we subtract as long as they're common, and 6 minus 5 is 1. So this one is good. But if you look, 6/6 minus 5/6, that's exactly what we have here. And instead of doing that, they just left it as an unknown. Could that work? It's the same exact thing we wrote. You bet it can. Could we rewrite this? She ate 5/6. 5/6 plus an unknown is going to equal 6/6. That doesn't really look like an equal. It looks like a greater than. So, yeah, that's also good. So your best answer here was all of the above. This next one, obviously, if it's 120 degrees, that's bigger than 90. 90s are cut off. Less than 90 is acute. More than 90 is obtuse. So here you should have had obtuse. It's kind of hard for me to draw it on here, but I would imagine it should look, there's 90. About another 30 onto that would be somewhere in there. That's probably, and then you'd need to label it L, M, N. The M needs to be the vertex, the middle point. It could be L, M, N. That would also be acceptable. I wouldn't mark that wrong. Problem 5, doing partial quotients division. All right, so for this first one, I think I can probably make this one a little bit bigger, maybe even, so that it's easier for us to look at. Slide, that's probably good right there. Slide this line down. Okay, so in this one, your divisor is 6. We look at the 8. How many times can 6 go into 8? It can go in there 1 time. We're just working with the 8 here. So 6 times 1 is 6. We put the 6 underneath that 8. Then for the other place values, we're going to add zeros. If I add 2 zeros in there, I need to add 2 zeros in here. Because 6 times 100 is 600. And we subtract. You get a 4, a 9. 4 minus 0 is 4. 9 minus 0 is 9. 8 minus 6 is 2. Now, 6 can't just go into 2. I wrote it a little bit bigger so that we can work with this now. But 6 can go into 29. So, I can't do 10. Well, I could do 10, but it's not going to get me as far. But really what I'm thinking is, what times 6 gets me close to 29 without going over? And 5, 6 times 5 is 30. Well, that's a little bit too big, so I know 6 times 5 won't work. I could do 6 times 4, though, because it's going to be less than 30. 6 times 4 is 24. Add a 0, add a 0. Now, you might have done different steps than me. You might have just done 10, and that's fine. Yours is going to be a little bit longer. It doesn't matter the steps you take as long as we get to the same place. 4 minus 0 is 4. 9 minus 4 is 5. 2 minus 2 is 0. I'm not going to bring that down. So now we're thinking, what times 6 is 54? There's no remainder on this one. And again, if you're not sure, you could try 10. 6 times 10 is 60, but that won't work. It's got to be smaller than 54. Again, that tells me I can probably do 9. Forget about the 9. What's 1 less than 6? 5. 5 plus what is 9? 4. Little trick for your 9, something that we've talked about in class. 4 minus 4 is 0. 5 minus 5 is 0. So we're done. When your remainder is smaller than your divisor, you are done. 100 plus 40 is 140 plus 9, 149. Let's take a look at this next one. Can 9 go into 55? Or can it go into 5? No. 9's bigger than 5. So that means we have to work with 55. But the nice thing here is, sometimes you got to be smart. You got to use what you've already done. We know that 6 times 9 is 54. So I'm going to do a 6 right off the bat because 9 times 6 was 54. Now because I'm working with the 55, I can write both of those digits underneath the 2 5s that represent 55. I know they're not 55, it's 550. But we're going to make that adjustment when we add our 0. Because it's really like multiplying this by 10. 9 times 6 was 54. 9 times 60 is 540. And now we can subtract. 8 minus 0 is 8. 5 minus 4 is 1. So now we're just doing what times 9 is 18? And that is 2. 9 times 2 is 18, and you subtract, no remainder here. Answer for this one, 62. 60 plus 2. And the last one for today was just adding fractions. Number model, 1/10 of a book, got that one. 3/10 on Tuesday. 1/10 on Wednesday. 2/10 on Thursday. And 2/10 on Friday. When your denominators are common or alike, you can just keep those the same. We're going to have tenths. 1 and 3, 4, 4 plus 1, 5, 5 plus 2, 7, 7 plus 2, 9. Should have ended up with 9/10. All right, those are your math boxes for today. And stay tuned, I'll have your new lesson posted soon.